Number 7 is going to be another one of those comparison questions where we can compare different situations, different principal values, and different interest rates to see which one pays off and to see if we can make some predictions about what seems to be the most advantageous as investments go. Is it better to have a higher rate, bigger initial deposit, more time, etc.? So in question number 7A, we're wondering which of these 3 grandchildren will earn more money if the investment period is either 5 years or 10 years. So it looks like what we're going to have to do is to calculate each of the 3 individual kids with each of their individual formulas, and then we'll compare to see which one is the most profitable. So I'll start with the 5-year. I'm going to give myself a little bit more room because I'm going to write my formulas. You don't have to write the formulas. This is just one of those habits of mind, especially as you're learning it for the first time, that might be helpful to think about. If we think about reading the question, we have to be careful that we have our 2 different formulas, and we have to make sure we're using the right formula for each child's situation. So Alice, for example, is getting a $500 deposit. That would be her principal. So both equations have a P. That's not enough to tell me what I need to be looking for yet. And then it just says 1.1% annual rate. It doesn't say continuously though. So the fact that it doesn't say continuously makes me think we're using the second formula, the 1 plus r over n to the power of n times t formula. Because that, without the word continuously, seems to imply we're only compounding once a year. That's a set frequency. That's a set amount of time. We're getting the money once a year. To say you're getting it continuously, that's not a set amount of time. Continuous isn't a number. So a set frequency is like this Alice situation, once a year, or quarterly, 4 times a year, monthly, 12 times a year. The set frequency is definitely when you're compounding a set number of times per year, like n is an actual number. Continuous is when it says the word continuously, which you can clearly see in both Bridget and Charles's examples. So that's how I can tell for both of these folks, we're going to be using the PERT formula instead. So I definitely wanted to make sure I knew which formulas I was going to use before I started the question, because that's a good way of making sure you've organized your info. So let's start with the first grandchild, Alice, and let's start with her 5-year calculation. We have our formula, we just need to plug everything in. So P, that's her $500 deposit, parentheses, 1 plus R, that's her interest rate, 1.1%, but I have to convert it to a decimal, so move the decimal 2 places to the left, that's 0.011, divided by N, that's how many times a year, or the frequency you're compounding. It doesn't say we're breaking up the year into smaller amounts, so we can assume that she's getting it annually 1 time a year, since they didn't say otherwise. Then close the parentheses to the power of n is 1 again, because it's the same n, times t. T is 5 years. So I'll plug all of that in. You can definitely use some mental math if you want to, just so you can save yourself some keystrokes. Otherwise, you can type it exactly as you see it, 1 plus parentheses 0.011 divided by 1 to the power of 1 times 5. Again, you can type it as you see it, or you can do mental math to clean this up a little bit before you type. That's your choice. But it looks like Alice is going to earn $528.11. So pretty good. Let's compare to the other 2 grandchildren, see if her deal ends up being the best. The second grandchild is Bridget. Bridget is going to use PERT because she's compounding continuously. Her P, or principal, is 500. E to the power of her interest rate is 1%, so move the decimal 2 places to the left, that's 0.01, times her time is also 5 years. So again, you don't have to write it, you can type it if you want to save yourself that redundancy. 500 e to the power of, I always type with parentheses whenever I have 2 numbers in the exponent spot. It's a good rule of thumb, just like using fractions with parentheses, same idea. 0.01 times 5, and that looks like Bridget is getting $525.64. So she's earning a little bit less than Alice. Okay, let's look at Charles. Charles is also going to use PERT. Charles has a $200 deposit, poor Charles. e to the power of, he's getting a 5% interest rate. Ooh, so maybe he's actually going to benefit because his interest rate is so much better. Move the decimal 2 places to the left at 0.05 times time is 5 years. And let's check that. 200 e to the power of parentheses 0.05 times 5 years. Oh, turns out poor Charles is still being hampered by a smaller initial investment. He's only going to get $256.81. So of the 3 grandchildren, the one who is clearly benefiting most in the 5-year span is Alice, because she's earning the most money. Now, of course, you might be willing to say to yourself things like, okay, well, that means that compounding continuously isn't as good as compounding annually. And you might not want to make any broad generalizations because honestly, there are several variables in these problems that all seem to take effect. The primary reason why the continuously wasn't having much of an effect, especially for poor Charles here, is because 5 years just isn't that much time. In fact, if I go through and do the exact same calculations but with 50 years, and I'm going to do this quickly just so you can see the benefit of the copy and paste feature in the calculator if you have one. If I changed my, oops, that was the wrong change, my bad. If I change my time to 50 years, so instead of 5, notice I changed my time to 50. Alice's 50-year investment is $864.03. If I go back to Bridget's investment, change the time to 50, she's up to $824.36. And if I change Charles's, whoops, to 50 years, notice Charles's number, $2,436.50. The other kids are getting $800. He's up to $2,000. So clearly, if you let his investment ride for a long time, it doesn't matter that he didn't have as big an initial deposit or principal value. His interest rate is what took him so much further ahead of the other two in the long run. But you can tell we needed a long run of time to be able to see that benefit. In 5 years, these two were probably laughing at him like, oh, boy, who's the least favorite grandchild in this family? And all of a sudden, 50 years later, there they are as probably older people, and Charles has the last laugh. So, you can tell you have to pay attention to multiple factors here. What is your principal investment going to be? How much are you going to let it sit for? How much time are you going to let elapse? And are you going to negotiate for an interest rate? You have to pay attention to the effect of each of those things to see what's going to happen. Hopefully now that gives you enough information that you can start to kind of think about how exactly you would use these formulas. For the most part, the question will give you all you need. You just need to adapt it into the formula and use a calculator to do the heavy lifting. The only question I don't think anybody should bother with from this point forward is question number 9. It was meant to be an investigation that, again, we would have done in class with a graphing calculator, so you can skip question number 9. But I think at this point you should be well equipped to finish number 7, letter B, and finish number 8 so that you can practice compound interest. Tomorrow's lesson doesn't have any videos attached to it, but tomorrow's lesson will be page 19, and it's simply more practice of our investment formulas. So make sure that you make a note to yourself before you get to page 19 that you'll be making absolute certain that you understand your 2 types of formulas, understand how to use them, and make sure that if you have any questions, you either pop into the Zoom or send me an email so that when you're on your own for page 19, you'll have a pretty solid idea of what to do.